In this video, we are going to do problem number 31, take. So the 31.0 problems have to deal with having a number as a recursive type. So if you remember all the way from some other sections ago, we can treat numbers as recursive types. If we treat 0 as the base case and the recursive case as add 1 onto natural, right? And this is what the recursive template looks like, where we check for 0 as the base case, and the recursive call is going to be n minus 1. All right, so this time we're going to have a list and a number, and we're going to treat that number as a recursive type. All right, so 31 take, I already have it downloaded and opened up in Racket. So let's just go down here and read problem A. So problem A, design the function take. It consumes a list of anything and a natural number n. It produces the first n items from the given list, or all of the list if the list is too short, so smaller than n. For example, given take, and here's list 4927, we want to take 3 things, the first 3, right? So it produces the list 4, 9, and 2, right? Because we only want the first 3 things, 1, 2, 3. So this 7 gets excluded. All right, so if n is, way larger, way smaller, let's say 0, right? Then we're just going to produce the entire list, right? And you can come up with more examples as we'll see shortly. All right, so pause the video and try to do this on your own. I'm gonna go over spoilers in 3, 2, and 1. All right, I'm assuming that you guys already took a good swing at it. So now let's go over it together. So signature, take consumes a list of anything. So we can do list of numbers for now, and then we'll come back and make the signature a list of anything, right? Because numbers are kind of easier to think about and type out. So list of numbers and then a number for how many you want to take. And this whole thing produces a list of number. All right. So signature purpose produces the first n items of the given list. Signature purpose, we can stub this out, define take. So we'll call this parameter lst and num. All right, because that's what we are consuming. And this whole thing produces a list, so we can use empty as a dummy value. All right, so now for some tests. How many tests do we need? Well, if we go back to the example over here, let's see. We needed 4 things for the case where we were consuming 2 lists, right? We were given 2 input lists, like so. So we would need 4 cases if we were to treat the recursive number as a recursive type, right? Because the recursive type can be 0 or greater than 0. So it's going to look something like this, right? Where we check if the list is empty and the number is equal to 0. So that's the base case for the number over here, right? We need to check if the case for if list 1 has items in it and num is 0, and if num is non-zero, and if list 1 is empty, and then both of them are non-zero and list 1 is non-empty. Right, so those are the 4 tests that we need. So let's just write them out, right? So check expect, take, let's see, it takes a list, so we can use the empty. We're doing the empty and 0 case first, right? This box over here. Right, what should this produce? Well, this should produce the empty list because we're taking 0 from an empty list, so we're taking nothing from the empty list. So that should produce the empty list, right? We also have to produce a list of numbers, so yeah, we have to produce the list at the end of the day anyways. All right, let's do the next test, right? This one, where list 1 has items and num is 0. So this is list 1. It has items, we'll say list 8, 9, right? What should this produce? Right, 0 of 8 and 9. Well, it produces the first n items from the given list, or all of the list if the list is too short. Okay, so that's a different test. So this should produce empty because we're taking 0 from this list. We're taking nothing from this list, so produce nothing, empty in this case, right? All right, so now comes the third part, which is if num is non-zero and list 1 is empty. So if num is non-zero, so I'm just gonna copy paste this. So let's say num is 2 and list is 0, so empty. All right, what should this produce? Take 2 of the empty list. Well, it's kind of nonsensical, right? The empty list, how can you take 2 things out of a list that has nothing in it. So that should produce empty. All right. So now comes these tests, right? Where the list has things in it and the number is greater than 0. So they already gave us one test, so we can just write that down. So like so. All right, this produces the first 3 items like so. All right, let's do this case over here, right? Produces all of the list if the list is too small, right? So we'll say if the list is too small, I think by that they mean something like 4927. If the list is too small, so we'll say like 100, right? N is 100. Can we take 100 things out of a list with only 4 elements? Not really, but we can say, all right, well, looks like you want a lot, so we'll just give you whatever we have up until the number 100. All right. So let's come up with different numbers just so that we don't confuse these two tests. Let's come up with 7, 2, 4, 6. All right. Like so. All right, so those are good enough tests, and we get some differs. That's fine. We can comment out this stub, and I recommend you to grab the template. We can template it right now. So actually take lst num. All right, so we have 4 cases, right? One of the cases is if the list is empty and the num is 0. So if the list is empty, and the given list is empty, and the num is 0, so 0, num, right? And this is already wrapped into an and. We do something. Otherwise, we do the other case, right? If list 1 has items and num is 0. So if list 1 is empty, non-empty, so that's cons, right? You can see it here, cons, the list. Right, don't write cons, write cons question mark. It's just 1 letter difference. And the num is 0, right? Do something. Well, what can we do, right? Since we know that the list has items in it, we can take the first and rest of it. And the num, it's 0, so we maybe could use it, maybe could not, but let's just do the first of the list. Since we know there's something in the list, so we can take the first of it, and we can take the rest of the list. All right. So let's do the third case. So, and this is this case over here. If num is non-zero and list 1 is empty. So if list 1 is empty, so if the given list is empty, and this is non-zero, so it's greater than num, and then 0, right? That's a non-zero. All right, if so, we want to do something. Well, what do we want to do? Let's see, we have to do the recursive case over num, because num, again, we're treating that as a recursive type. So we're going to minus n by 1, and maybe we can possibly use n, right? We can't take the first of the list because it's empty in this branch. And if we take the first of an empty list, then we get an error. So we can probably do something with the number, and we probably need to subtract the number by 1. And that's probably going to have to be wrapped into a recursive call. So we'll get to that later when we get there. All right. And then the last case is this one over here. If num is non-zero and list 1 is non-empty, right? So if the list is non-empty, so we can determine that by cons question mark lst of the given input list. And then if the number is non-zero. So this is how you check if it's non-zero. All right. So what do we know about this branch of data, right? Well, we know that the list has something in it, so we can take the first and the rest of it. So we'll likely need this. We're just laying out all the pieces. And then num is greater than 0, and we're treating it as a recursive type, so we probably want to subtract num 1, right? All right, so this is the template. We probably need to wrap some of these in recursive calls. I already see them, like so. But nonetheless, this is laying out a good set of good scaffolding that we'll use towards our solution. So I'm going to comment this out, and I recommend you pause the video and try to do this on your own. Hopefully this should be all the mental scaffolding needed to solve take. I'm going over spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it, so now let's go over it together. So given this first test here, if the list is empty and the number is 0, the natural number is 0, then it looks like we just produce empty. All right. So second test here, if the list has something in it and the number is 0, well, produce empty it seems. So it turns out that this template for this problem we don't really need. All right, so third case over here. If the list is empty, but the number is non-zero, right? Well, it looks like we just produce empty, all right? So this is also not really needed. Okay, so let's keep going for this case over here. Let's see, and cons. Okay, so this is if the list has things in it and then num is greater than 0. Okay, so looks like we want to, looking at the signature here, we are building a list. So we are going to need cons, right? Because cons is the only thing that can build a list. So we're going to take the first item. So it's going to be these two tests over here. We want to take the first 3 items. So we're taking, this is going to be the 4 in this iteration. And we still have 9, 2, and 7 to go. So the rest is going to be 9, 2, and 7. And we want to subtract 1 from the number because we took 1, right? We took the 4 over here, and we only want the next 2. So this is that's why that sub 1 was there in the template. So let's just call this recursive call on take and assume that it works, right? Like so. I'm going to space this better and run this code. And we see that all 5 tests do pass. All right, so now test, review, and refactor. So what can we eliminate from these looking at the tests over here? And also, if you put them in the table method, let me just grab the table over here and fill out these 2 rows, right? We see that that's going to be empty for this case, where both of them are empty. And then for the second case, it's the first list has things in it, the second thing is 0, so that's also empty. So empty, this is also empty, and then this one is something in it. But nonetheless, right, these, we can merge some of these, right? We can eliminate some things. So let's see, if the list is empty and 0 it's 0, the number is 0, then produce empty. And then let's focus on these 2 tests actually. So if the list has things in it and the number is 0, well, if the number is 0, right, trying to talk through the problem itself, right, take 0 from the list. Take 0 from the list. So if it's 0, then you're not going to take anything from the list, right? It doesn't matter what the first list, whether it's empty or not, right? If we're taking nothing, then we're going to produce nothing. So this can just remove the check for whether or not the list has anything in it. Because if we take nothing, then we're just always going to produce nothing. So we can just delete this just over here. And since we delete that, it says that and expects 2 things. So we can delete the and like so. Run this code. Looks like all 5 tests still pass. All right. And this test is arguably similar, right? If the list is empty and we're trying to take 2 or 100 from it, it doesn't really matter what the number is, right? If the list is empty, if what I'm trying to take from has nothing in it, right? The number can be as high as it wants, right? It doesn't matter. There's nothing to take. So we can remove the check for this, the number over here, right? If the list is empty, then produce empty. And we get the and expects 2 arguments, so we can delete the and itself. All right, like so. And looking at these 3 tests now, right? This and empty, the list is empty and 0 is empty. Well, this is pretty much covered by these 2, right? It's just spread out into 2 sort of statements in a sense. And let's just try deleting it and running it. Looks like the test will pass. So we're still getting the same behavior, just less branches of code, right? So we can delete that case. And yeah, if you talk through this case, you will find that, hey, if I'm taking nothing from nothing, then produce empty. Well, if you're taking nothing from something, 0 from something, then you're going to end up with nothing. And likewise, right? Just elaborate it and you can find things that you can delete, like so. And lastly, since this is the last case of this con here, we kind of don't need to check for this case, right? If the list has something and the number is greater than 0, this whole thing just can be else, like so. And I like to space this down so I can see the cons, first argument, second argument, right? So take the first n things where the n gets smaller every recursive call, and the list gets smaller as well, because we took the first thing and we took the first thing the list and stuck it there. And so we got to make the list smaller. All right, so we run this code again. All 5 tests do pass. We successfully simplified it from the 4 case cond to this more simplified version. All right, and all the 31.0 problems, I'll try to add more that require you to have a list and treating a number as a recursive type, a natural number, right? So you have to subtract 1 in each recursive call. I'll try to add more problems. And yeah, note that this case, right, this problem, it looks like for this last case, it's lockstep, right? We're taking the rest of the list and we're subtracting 1 at the same time. So it's pretty much this case, right? There will be problems on numbers and lists that are like this, where we process only 1 at a time, and maybe the number stays still. That's going to be often the case, and sometimes at different rates, right? There's going to be some problems like that. So watch out for that, right? The number case is a variant where we treat the second item here as a number, right? The list as a number, because normally we were processing 2 lists. Now, one of those lists, we're treating that as a recursive type over numbers. So this is not list in a sense that these boxes represent recursive types. All right. So yeah. So submit this into hand-in, check your score, and try to do the rest on your own. All right.